All right, I'm going to make a video that goes with the section 5.8 handout that you got today. All right, so what's going on in section 5.8 is we're going to be looking at expressions that can't be integrated using the techniques from section 5.5. They look like they might be able to, but they can't. All right, so I want you to look at question 6 for just a minute to understand why we need these formulas. Okay. But I don't want you to write down what I'm about to write down. So what you might think that you would do on this one would be to see the problem as though it's 12 times 1 over 1 plus 9x squared dx. Think of it kind of like that. And you might be thinking that I don't see why I have to learn something new, because couldn't I just take that 1 plus 9x squared and treat it like a u? And then basically what I have is 12 times 1 over u. And then I should be able to just integrate that and come up with the natural log of u plus c, and I'm done. The problem is that if you can continue the process from section 5.5, you would wind up with an 18x dx over there. And you see there's no x up in here. Okay, I don't mind the 18. I could have taken care of that, but there was no x in there. So that technique wouldn't work. So we'd need something else. So when that happens, when the techniques that we know from earlier sections don't work, then we have to think about, hey, could it be one of these that winds up being an inverse trig function? All right, now back when we first looked at inverse trig functions, this was back in chapter 3, where you were doing derivatives of inverse trig functions. So they can give you a sense of how this is going to wind up working. So you kind of see it right here. It's basically what we did back in chapter 3, but we're trying to reverse that process. All right, but there's a little more to it, or not a little more. It's generally something where you would just have to know these formulas or be able to find these formulas and then make use of them. Okay, so let's look at how number 6 would have worked. Chapter 3, we were actually doing derivatives, and then here we are doing the integrals in chapter 5, and this is what's going on in 5.8. All right, so I just demonstrated that problem number 6 can't be done just thinking about it as a natural log problem. Okay, and so what we're going to wind up doing on this is looking at those 3 formulas and noticing that this problem number 6 doesn't have a square root in it. So this is probably going to be arctan. Okay. Then as we look a little bit further, we notice, hey, yeah, I need, in the denominator, I need this a squared plus u squared concept, and I can kind of see that. Now, in all of the formulas, the a that you see is a constant, and the u that you see is an expression involving the variable. Okay, and then the a and the u might be in the order they need to be in to apply the formula, or they might be reversed. Okay, so on this one, it is arctangent. Things are pretty much set up in the order they need to be set up in. I just have to learn how to identify the u and the a. So I know that the a squared, that's going to come from the 1. And so if a squared is 1, then a would be the square root of that. Okay. You don't have to worry about the plus or minus. We're going to be using the 1. Okay. And then the u is going to, let me move this over a little bit more. Okay. So the a came from that first number, the 1, and that 1 represented a squared, so I did the square root and wound up with a being 1. And then do you see how the u squared is supposed to be what's after the plus sign, and that's the 9x squared. If I square root both sides there, then what I'm going to wind up with is the u being 3x. Okay. All right, so now we're going to kind of do what we did at that point. At this point, we're going to do what we did in section 5.5. We're going to do the derivative with respect to x, write it in differential form. We're going to look over here at how to get the u's in there. So I'm going to move the 12 there. I have 1 over 1 squared plus the 3x squared with a dx on it. Okay, so I'm just trying to get it written so I can compare better to that formula and see what I do where. All right, so I'm not integrating yet. I'm just putting u's into it. Okay, so this would be 1 squared plus u squared. Okay, and then in place of the dx, I'm going to have to adjust over here. I'm going to move the 3 out of the way. And so dx would be 1/3 du. So I'm going to replace that with 1/3 du. Then the 12 and the 1/3 would become 4. Okay, and so there I now have taken a little bit of time to get it rearranged and written so that I can compare it exactly to that formula. Okay, so do you see right there? There's that formula. Okay, all right, so now I'm going to do the integration. So the 4 just gets carried along. All right, then I'm going to need 1 over a, and a happens to be 1. Then I'm going to have arctan of u over a. I'm going to go ahead and plug the u back in, which is 3x. The a was 1, and then don't forget the plus c. And so I wind up with 4 arctan of 3x plus c. Okay, and that's it. So it boils down to recognizing that it's an inverse trig function related problem, and then correctly identifying the u and the a to apply to the formulas. All right, so back to the formulas. All right, basically you need to know these. You're supposed to know these. Okay, it's supposed to learn these. All right. Now, in Calculus 2, this happens a lot because sometimes you're trying to integrate a rational function and you wind up using division to rewrite it, and the very last term winds up being something that looks like that right there. And so then you recognize it as an arctangent type situation, and you go from there. You will sometimes use the others, like this one you'll sometimes use. You don't come up with arcsine that often, but the arctangent all the time, arcsecant some of the time, okay? All right, so you're supposed to learn these. There is one question on the final exam that will involve knowing that formula right there, knowing those formulas right there, okay? All right, we're going to work with it here, and we'll talk about it on Tuesday a little bit more. All right, so let's try another problem. All right, so let's look at question number 4. All right, so on that one, I see a radical, so I know it's either arcsine or arcsecant. I know I can't just use what I did in 5.5 because the derivative of the inside function would have been negative 8x, and I don't see an x anywhere. So that's why I went or why I would think that maybe I need to use one of these formulas. All right, so it's either the arcsine or the arcsecant, and arcsecant has this extra little u out in front, in front of the radical, which I don't have. So this is going to be an arcsine problem. Okay. All right, and so on this one, I'm going to wind up trying to rewrite it so it sort of looks like what I see the formula looking like. So I'm going to think of it as 1 over the square root of. The 1 is really the 1 squared. And then that u, okay, so the a squared is really the 1. And so a would just be 1. And then the u squared is what follows the minus sign. So it's just the 4x squared part of that. And so when you take the square root of both sides there, you wind up with square root sign here. You wind up with 2x for your u, okay? So this is square root of 1 squared minus the 2x squared. And then I'm going to write that dx off to the side, so it really is going to wind up looking just like that formula when I get ready to plug everything back in. Okay. All right, so now I go back and do the derivative with respect to x. That would be du equals 2 dx. Okay. So now I'm going to come back to the problem and put the u's in, get it to look just like that formula. So this would be 1 squared minus the u squared. And then in place of the dx, I'm going to put 1/2 du, because dx equals 1/2 du. Okay. All right, so the 1/2 I can really move out of the way. And I can focus on this 1 over square root of 1 squared minus u squared du. I'm trying to integrate that. All right. All right, so when we go to integrate, our answer is just going to be arc sine u over a. Arc sine u over a. So it's going to be arc sine, and u was really 2x. A was just 1. Okay, so that's what I get when I integrate this part, but then don't forget that constant has to be brought down, and don't forget the plus c, and then 2x divided by 1 is really just 2x, so you wouldn't write the divided by 1, and you'd wind up with this right here. Okay, so you get your 1/2 arc sine 2x plus c. Okay. All right, so let's try one more. I like to keep these videos kind of short so they go through easily when you're trying to open them and look at them. All right, so why don't we go ahead and look at the bottom right problem. So on that one, I'm looking at it. I see a t to the 4th plus 16. I don't see a radical, so I'm thinking it's going to be a tangent type problem. I'm concerned initially about that little t that I see sitting there, but maybe it's going to be okay. I know I can't do this using my old approach because the derivative of t to the 4th plus 16 would have been 4t cubed, and I don't have a t cubed anywhere. Okay. All right, so when I go to compare, this one doesn't have a square root on it. So I'm comparing back and thinking it's going to be an arctan problem. Okay. So I'm thinking about it being arctan. All right. Now, when I'm looking at the way the formula is typically stated, it normally has the numerical part first and the variable part second, but addition is commutative, so I know I can do that, no problem. So I can think of it as 16 plus t to the 4th with no issue. And then I'm just going to move that t that was on top over here with the dt, because I'm probably going to make a substitution that involves that in a minute. All right. So now we want to kind of think about things. So we know our a squared would have been the 16, which means a would be 4. And the u squared would have been t to the 4th power. So when you do the square root of both sides to get that, I don't need it on that side, with square root of both sides, I'm going to wind up with the square root of t to the 4th would just be t squared, wouldn't it? Okay. All right, so now let me go ahead and do the du. When I do the du, the derivative of this, with respect to x, I'm going to get du equals 2t dt. And now I'm happy that t was there because see, here's the t dt. Okay. I don't want the 2, so I'm going to multiply both sides by 1/2. Okay. And then I'm ready to come back over here and start trying to plug things in. All right. And get it. I'm trying to get it to look like that formula that we had. So be looking at that formula on the sheet. So the 16 is really the 4 squared. Okay. The t to the 4th, think of it as t squared, and then that t dt that's sitting there. Okay. So this is 1 over 4 squared plus the u squared. I haven't integrated yet. And then t dt I'm going to replace with 1/2 du. So the 1/2 I'm just going to move out in front of it for a bit and be thinking about this part right here. Okay. All right. All right, so now we're ready to go to the formula. So now I'm ready to integrate. So the 1/2 from here is going to just get brought along. Now I'm going to the formula, and it says that I should get 1 over a, and a is 4, okay? And then I should have arctan, and I should do u over a, and u was t squared, so I'm going to go ahead and put that back in, over the a, which is 4, and then I'm going to put the plus c. And then I'll clean it up slightly. 1/2 times 1/4 would be 1/8. And then I have arctan, t squared over 4, plus c. And that will be my answer on that one. All right, let me see how many I have left. Yeah, I'll stop on this and then do one more video that has the remaining ones.